Okay, looking at the review, let's look at number 10. Did you have a guess for what u should be? Yeah, I think u should be sine. Oh, it's already in u. So we can do a u substitution. That's kind of misleading. Let's pick a different variable though. Let's just say v equals sine of u. So dv equals cosine of u du. That's good news. That's dv. So this is v to the negative 12 dv. So increase the power by 1, divide by the new power. Negative 12 plus 1 would be negative 11, divided by negative 11, plus c. So let's see, what's the easiest way to write this? 1 over 11 sine to the 11th of u plus c. Yep. Weird looking answer. Other questions?
Number
5. Nick, you got a guess for what u should be? Long division is for when the top power is bigger than the bottom power, not when there's a natural log involved. What's the derivative of natural log? Not 1 over natural log, but 1 over x. And we have a 1 over x. So let's let u be 2 minus natural log of x, because derivative then would be, well, negative 1 over x dx. So if we put a negative on there, then we've got du. So this is u squared du. Do you want to? So we have an option here. We can integrate that. Actually, let's keep going. Right. The options are: do I want to switch it back to x's and use e and 1, or do I want to switch my limits so that I can leave it as u cubed over 3? It doesn't matter. I think switching the limits is probably the easier way to go, rather than putting 2 minus natural log of x back in there. So I need to figure out what u of 1 is. 2 minus natural log of 1. By the way, if you really got stuck, you could just leave that as u of 1. And that would be your top limit is 2 minus natural log 1. Like if you get stuck on natural log of 1 or sine of pi over 2, you can leave those answers. You just have a really long answer, but it'll be correct. And it'll be calculator ready. But natural log of 1 is 0, so the top limit is just 2. U of e, 2 minus natural log of e. The natural log of e is 1. 2 minus 1 is 1. So negative 8 over 3 minus 1 over 3. So that would be 7/3, and then put the negative on there, negative 7/3. Although, safe stop, you could have stopped right here and been okay. Right. Both of those were kind of old news problems. We still haven't done an inverse sine or an inverse tangent. Or a long division. do see a long division problem in there. It's number 3 is a long division problem. Would you like to see number 3? I'd love to see number 3. How did you know that it's a long division problem, I guess? Yeah, if the top degree is bigger than the bottom degree, then it's long division. So the 5th grade algorithm still holds. Something times x squared gets me to 3x cubed. Well, that'd be 3x. So 3x cubed plus 6x. Change the signs. Negative 13x. So minus 13x over x squared plus 2. So again, we're not done yet. We haven't even done calculus yet. That's algebra. So the integral of 3x minus 13x over x squared plus 2. And maybe it would help to split them up even further. In fact, I'm going to put the 13 out front, because I don't think 13 is going to help me with a u du situation. So I just move it out front. So the first one, up the power, divide by the new power, so 3x squared over 2. That was an easy one. That second one, though, it looks a little bit like inverse tangent, because it's got x squared plus a squared in the bottom. But it has an x in the top. So what do you think we should let u be so that du shows up? The bottom. X squared plus 2. Because then du is the top. So that'll account for that 2x up there. Well, for the x up there, and then I can make it a 2. So I've got du over u. I'm short on space, so what's the integral of du over u? Natural log. So minus 13 over 2, natural log of x squared plus 2, plus c.
Is number 9 just one of those, one of those ones that we just have to know?
Good question. Number 9 is one of those that you have to know. Hopefully you recognize that and you're thinking, wait a minute, there's a function I've seen whose derivative is secant tangent. Maybe you want to take care of the 5 thing, but so who has a derivative of secant tangent? Just secant. Again, some people wouldn't even show the u du stuff because they could just undo the 5 bit on their own. What about 6 and 7? They look similar. What technique are we going to be using, or what's the answer going to look like for 6 and 7? Inverse sine. What about number 8? Probably tangent, right? Because if I let u be the bottom, then the du would be 2x minus 6, and I don't have any 2x's to fix, so I think this is going to be an inverse tangent with a complete the square. For 7, I just move the 8 out front, and then you'd be ready to answer it. For 6, you'd have to do a u du fix with the 5, something with a 5. Do I need to do 6 or 7 or 8? Or do we do enough of those where you're okay with them? How about 13 or 14? I feel like it's been a while since we've done a derivative of inverse cosine or inverse tangent. It will be fine, or we should see one of those? 14. So derivative of tangent, I can remember the rule here without looking it up, is, I know it's in the bottom, it's a squared plus u squared, and then the du for the chain rule. So sine and cosine have the square root and a minus sign, so they're more complicated. Tangent is the one that's a little more straightforward. So g prime of x would be 1 over a squared. Oh, it wasn't a squared, right? It was just 1. 1 plus u squared. Because there aren't any a's. So 1 plus 2x plus 1 squared, and then chain rule times 2. Sine and cosine are 1 over square root of 1 minus u squared du. And the sine is a plus and the cosine's a minus. So this one would be 7, just along for the ride. Inverse cosine, so negative. Square root of 1 minus 2x squared times 2 for the chain rule. And you can leave it like that. That's an acceptable answer. If you just make sure that 2x is squared, so in parentheses, or you could write it as 4x squared. Other questions? Done a bunch, and I